Hey, Mike. What day is it? You know what day it is. Hump Day! Time for your favorite day of the week, the day I make the video. Although most of you will probably watch this on Thursday or Friday, so maybe this won't, or even Saturday or Sunday for the B-Day people. So this might make zero sense to you. But anyway, let's get on with it. Please start off by writing lesson 5.3, kite and trapezoid properties. To remind you, there's our kite on the left, there's our trapezoid on the right. We got the kite right here and the trapezoid right here. And what you can see is it labels things, and I do want you to draw these. It labels the non-vertex angles. And you can see these two sides I just labeled in blue are congruent, and these two sides I labeled in red are congruent. And so the non-vertex angles are the angles that are in between the sides. So they're in between the sides that are not congruent. Whereas the vertex angles are between the sides that are congruent. Okay? It's a big difference. You've got to know that. We also have, in the trapezoid, you have base angles. They're pretty easy to remember because you have a pair of base angles that are on opposite sides of the parallel line, and a pair of base angles on the other opposite side of the other parallel line. So you can see these lines are parallel, set of base angles on the same line versus the other two base angles that are a pair on the other parallel line. Okay? So make sure you draw those. Pause the video if you have not drawn them, but I'm going to move on. Remember, for those in A days, you've done constructions of a kite. And so our kite is something that you can construct. I do want to quickly show you, if you forgot how to construct the kite, remember we're going to have our initial point. That'll be the top of our kite. And then we're going to get a distance. We're going to pick a distance. Doesn't matter what that distance is. And we'll make an arc. We'll come over to the other side. We'll make this arc. And then what we're going to do is change our distance, because we're going to come right down below it to make our kite. We're going to put a little point right there. Okay? Now we can come from that point, and whatever we want, again, we can change our distance again. Whatever we want that distance to be, we make a mark. We come over here, we make a mark, and then using a straight edge, we will connect those. And because we use the protractor, we use the compass, we know that's congruent to that, and we know this is congruent to that. They are not congruent to each other. That would be a diamond. That's a special type of kite. So, when you look and it says kite angles conjecture, the blank angles of a kite are blank. What I want you to do is write this down and fill in. The non-vertex angles of a kite are congruent. So again, you have to remember what the non-vertex angles are. They are the angles that are between the different sides. These sides are not congruent, and that's where the non-vertex angles are. Pause that if you need to finish writing the kite angles conjecture. You will need that for your notes. The kite diamonds conjecture. So that is, if you do have diagonals, my fault, the kite diagonals. Ooh, I misspoke. I was probably thinking of Taylor Swift or something. The kite diagonals conjecture. The diagonals of a kite, now if you were to measure them, what you'd notice, if you were to draw the diagonals, I'm going to go back to this screen. If I was to draw the diagonals using a straight edge across and here, what I'd notice, and you can probably see, is those lines are perpendicular. So I'm going back to the screen. The diagonals of a kite are perpendicular. Please write this in your notes. Diagonals of a kite are perpendicular. Make sure you have the drawing in there. And I'll even do that in a different color. They are perpendicular, 90 degrees. Pause that if you need to finish writing that. Now you have the kite diagonal bisector conjecture. The diagonal containing the vertex angles of a kite is the perpendicular bisector. Now this symbol I just drew means perpendicular. You can write out perpendicular, bisector. The diagonal containing the vertex angles of a kite is the perpendicular bisector of the other diagonal. So it cuts it in half. So the diagonal, we have our two diagonals. The diagonal containing the vertex angles, here and here, is the perpendicular bisector. So it's both makes a perpendicular line and bisects the other diagonal. So these two, I marked them, are congruent. You can see that I marked it congruent. So pause this video and write that down and draw that picture. Kite angle bisector conjecture. Okay? The blank angles of a kite are blank and blank. It is the vertex angles. The vertex angles of a kite are bisected by a diagonal. The vertex angles of a kite are bisected by a diagonal. So pause for that. Again, you don't have to draw this. You've already drawn it, but if you haven't, here you go. You need to get this drawing down. But now we need to move on to trapezoids. Again, that's why I went to that previous screen so you could see we just did kites. Now we are talking about trapezoids. And you have the trapezoid consecutive angles conjecture. So what are some properties of trapezoids? Well, one is the consecutive angles between the bases of a trapezoid are supplementary. Now you need to remember what supplementary means. That means that they add up to 180 degrees. The consecutive angles between the bases of a trapezoid are supplementary. Next, the isosceles trapezoid conjecture. The base angles of an isosceles trapezoid are congruent. The base angles are congruent. So again, base angles, base angles. So those angles are congruent. And the isosceles trapezoid diagonals conjecture. The diagonals of an isosceles trapezoid are also congruent. The diagonals of an isosceles trapezoid are congruent. So we have both the base angles of an isosceles trapezoid are congruent and the diagonals of an isosceles trapezoid are congruent. It reminds me of my love for Shakira when I was in high school and college is congruent to my love for Taylor Swift right now. So that should be a good analogy. They are equal. My love for both of them at those times in my life were equal, just like the diagonals of an isosceles trapezoid are equal. They are congruent. So you're looking at the diagonals. That's this and that's this. And they are equal. They are congruent. And that is the lesson. Please make sure you've gotten the notes down and the drawings down. Have a great night. Have a great weekend, whatever day it is. Today's a great day because it's hump day.